Excuse me.
Yeah.
How you got the probability to be 1 out of 5?
All right. So as I was saying, so the test consists of 40 questions, each having 5 options. We have 5 options. Out of the 5 options, only one can be correct, right? On a multiple choice, if you have from A to E, only one of the options from A to E can be correct, right? Right, Alex?
Yeah, I got it.
All right. Remember that we're dealing with P represents the probability of success. So the 1/5 represents the probability of getting the answer right. All right. So guys, let's move on to question 3. All right, so question 3 says that the following 2 acceptance rules are being considered for determining whether to take delivery of a large shipment of components. A random sample of 10 components. So the first one is that a random sample of 10 components is checked and the shipment is accepted only if none of them is defective. The second option is a random sample of 20 components is checked and the shipment is accepted only if no more than one of them is defective. Which of the 4 of these acceptance rules has the smaller probability of accepting a shipment containing 20% defectives? You must justify your answer with clear calculations. So the first one said that we had a sample of 10. So now is going to be 10. Or x is going to be equal to 0 because it says that the shipment is accepted only if none of them is defective. So our x is equal to 0. Our probability of being defective is going to be 0.2 based on the 20%. Therefore, the probability of not being defective is 1 minus p, which is 0.8. So we're going to solve for this binomial distribution. So we start by writing out the statement with probability that x is equal to 0. So it's equal to 10 choose 0 times 0.2 raised to 0, 0.8 raised to 10, which is equal to 0.107. So now we have a sample. Suppose we have the sample of 20, where n is equal to 20, x is equal to 1, because remember the question said that a random sample of 20 components is checked and the shipment is accepted only if no more than one of them is defective. So x is equal to 1. The probability of being defective is 0.2, and the probability of not being defective is 1 minus p, which is 0.8. And we substitute, so the probability statement is probability that x is equal to 1, which is 20 choose 1 times 0.2 raised to 1 times 0.8 raised to 19, which is going to be 0.058. So therefore, the random sample of 20 components has the smaller probability of accepting a shipment containing 20% defective. But remember, the question asks us to find the one with the smaller probability. So the one with the components had the smaller probability. So this question 4 says that there are 10 employees at Jones Fashion Store and 40% are males. What is the probability that of a randomly selected number of employees that should say more than 3 are males? So the first thing we're going to do is write down what we were given. The question is supposed to say that less than 3 are males. So the first thing we're going to do is write down what n is. So n is, we're going to write down what we were given. So n is our sample size, which is 10. P is our probability of being male. So if you're not male, you're going to be female. So 1 minus P is probability of being a female. Our probability statement or our function is probability that x is equal to n choose x times the probability of success raised to x times 1 minus probability of failure raised to n minus x. So we write our probability statement. So the probability statement of x being less than 3 is equal to the probability that x is equal to 0 plus the probability that x is equal to 1 plus the probability that x is equal to 2. And then all we're going to do now is to substitute the values into our binomial distribution function, which is probability that x is equal to 0 is 10 choose 0 times 0.4 raised to 0 times 0.6 raised to 10, 0.000466 plus so that x is equal to 1 is equal to 10 choose 1 times 0.4 raised to 1 times 0.6 raised to 9, which is equal to 0.04031078 plus 10 choose 2 times 0.4 raised to 2 times 0.6 raised to 8, which is the probability that x is equal to 2 is equal to 0.12093235. When you add all these huge numbers down here together, you get 0.1673. Remember, we always round off to 4 decimal places unless stated otherwise. Do you guys have any questions about binomial distribution? Anything you guys don't understand about binomial distribution? All right, so now we're going to be looking at normal random variable and probability distribution. Remember that this was a continuous probability distribution. Remember that binomial is a discrete distribution, while normal random variable is a continuous distribution. So normal distribution, it describes the overall patterns of a distribution. Yeah, the question was supposed to be less than. All right, so a normal random variable and a probability distribution, it describes the overall pattern of a distribution. And the area under the curve is always equal to 1. This is like the sum of probability. Remember that the sum of our probabilities must be equal to 1. So with normal distribution, the only difference is that the area under the curve is always equal to 1. It's the same thing as saying that the sum of all probabilities should be equal to 1. So we have a couple notation where if we're dealing with a population, or mean is represented by mu. The person whose mic is on, can you please turn it off, please? All right, so if we're dealing with a population, the mean is represented by mu. And if we're dealing with a sample, the mean is represented by r. If we're dealing with a standard deviation, the population is represented by sigma. And if we're dealing with a sample, the standard deviation represented by S. So you guys need to know the different notation. This is very important. Then it says, suppose a variable X has a normal distribution with mean, mu, and a standard deviation, sigma. We write it as, we normally write it as X is normally distributed with a mean, mu, and a standard deviation, sigma. So this is the notation for representing a variable that is normally distributed. So we're looking at the first standard deviation of the mean. What it's saying is that mu plus or minus just the standard deviation should be equal to 0.68. So in layman terms, it's saying that the probability of X having a value between the mean minus the standard deviation and the mean plus the standard deviation is equal to 0.68. That's literally what it's saying. Then 2 standard deviation of the mean represents mu plus or minus 2 times the standard deviation, which is represented by this, which is equal to 0.95. It's just saying that approximately 95% of the data values will be between the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation. So in layman terms, it's just saying that the probability of X having a value between the mean minus 2 standard deviation and the mean plus 2 standard deviation is equal to 0.95. It makes sense for you guys to remember these probabilities. They're very important. Then what the 3 standard deviation of the mean is saying is that approximately 99.7% of the data values will be between the mean minus 3 times the standard deviation and mean plus 3 times the standard deviation. So the probability of X having a value between the mean minus 3 standard deviation and the mean plus 3 standard deviation is 0.997. So these are some of the values where you have to kind of remember them out of your head. So what does the mean and the standard deviation? So on the normal distribution, the mean is the center of distribution and the standard deviation is the spread. So what do you mean by the mean?